Hi, my name is Ashley Babinchak. I'm a senior bioengineering major and business administration minor at Clemson University, and I'm really excited to share a little bit more with you about Clemson Bioengineering. So first off, what is bioengineering? It also called biomedical engineering at some schools, very similar. So it integrates physical, chemical, mathematical, and computational sciences and engineering principles to study biology, medicine, behavior, and health. And we'll do this through developing innovative biologics, materials, processes, implants, devices, and informatics approaches for the prevention, diagnosis, treatment of disease, and patient rehabilitation. Basically, we're taking a little bit of physics, we're taking a little bit of chemistry, a little bit of math, and a little bit of coding, and applying that to problems that we see in healthcare. Simply, we're using our engineering skills, our physics, our chemistry, our coding, our creative thinking skills to create integrated, innovative technology to improve human health. So one example of this is a continuous glucose monitor, or CGM, in the lower left-hand corner. So if we kind of think about it, there's going to be a sensor that's attached to the body that's going to measure how much blood glucose or how much blood sugar is in the blood. So we're going to need to use some chemistry there to figure out how much sugar is in the blood. And then we'll need to use some coding, some math to figure out how we're going to make that into a number and then send that to a phone or another device so that the user can see what their blood glucose levels are. And another application we like to talk about a lot are stents. So here we have a blood vessel that has a lot of plaque on it. So plaque buildup can be caused due to a lot of things, but one of the things can be poor nutrition, something with a lot of fatty foods. And as this plaque builds up, the amount of space for the blood to flow through the blood vessel decreases. And so the blood isn't able to move around your body as well as it can and deliver all the nutrients to your body. And this can definitely be a problem. So one thing that we do to fix this is to have a stent. So a stent, it can be made of things such as metal, and this metal stent will expand and kind of push the plaque out of the way so that there's more room for the blood to flow through. And we like to talk about stents because it kind of brings us through the whole design process and some of the classes that you'll take at Clemson as a bioengineer. So first is a design class. You'll take SolidWorks, Engineering 2080, and you'll be able to create all of these different designs in computer softwares. And you really get to think maybe about how you would want to design these products. So maybe you want to use a lot of rounded edges or straight edges, or how long do you want it to be? How short do you want it to be? Really design what you want your device or your stent to look like. Next, you'll go into mechanical evaluation, and you'll use your knowledge from your biofluids, your biomechanics, and your biomaterials to figure out, okay, what materials do I want to use? How much pressure am I going to have from the blood vessel or the blood flowing through it? How is my design that I have going to work in the conditions of the body? Next, we'll have imaging. So you'll use your bioinstrumentation knowledge, learn about different imaging techniques, such as CTs, MRIs, or X-rays, figure out how we're going to image the body so we can see where to actually put our stent and where's the best place to put it, where the blockage is. And then lastly, you'll learn about surgical placement and how to talk with clinicians, maybe being like, so you figure out where you would want to put the stent, how to communicate that to the clinician. Next, I'll go into some of the careers that bioengineers have. It's really hard to sum up what a bioengineer does in one career. So we like to kind of divvy it up a lot into 4 main categories. So the first is the medical device and pharmaceutical industry. And this is also very broad. It can cover a large range of specialties, such as cardiovascular, orthopedic, or maybe even neurological. A mix of broad range of devices. Next, you'll have the government or regulatory agencies, such as the NIH or the FDA. These agencies are responsible for making sure that whatever the medical device and pharmaceutical industry puts out is safe and effective and be able to put on the market. Next, you could work at a hospital or a medical center. You could work there as a clinician. We do have a lot of students who are pre-med, but you could also maybe work there as a sales representative or someone on the staff, deciding what technologies to bring into a hospital. Lastly, you could work in university or academia. Suppose you go get your Clemson BioE degree, maybe go get a PhD and come back, do research, and teach the next generation of bioengineers. So looking more into the industry side, here's a sample of some of the companies that our alumni are at now. And there's a couple things I want to point out. So you can notice Pfizer, Johnson & Johnson, two of the companies that made some of the COVID vaccines. And there's a lot of, very famous companies such as those, but also some small ones such as Polymed. They're right down the road from us at Clemson. Another thing I want to point out is, there's a lot of companies here, and there are Clemson BioE alumni there. So whenever you're looking for an internship while you're at school or potentially a job after you graduate, you can reach out to some of our staff and say, okay, I really like these companies, and say, hey, I would like to work for these companies after graduate. Do you know anyone who works there? I'd love to get in contact with them. And so that's actually really helped me. I was fortunate enough to actually work for these companies over the summer. I did an internship at Arthrex in Naples, Florida. This past summer, I was the sterilization and biosafety intern. I absolutely loved it. I was able to apply the things that I knew from my bioengineering curriculum through my junior year into the summer, and then actually learned a lot at Arthrex. I was able to apply what I learned at Arthrex this year, especially in my senior design courses. So I highly recommend doing internships in industry and just reaching out to Clemson alumni, because there's always a connection there, and the Clemson family will help you get wherever you need to go. And so kind of putting some numbers to this, that look for bioengineers, there is an employment growth, a little bit more than other fields. And the average starting salary offer for someone with their bachelor's degree is about $60,000, with a median degree of $91,000 about. And this is, these are some numbers, but however, like we discussed before, there's a lot of different things you can do with your bioengineering degree. So, it could vary a lot. And just to kind of show what students do after their undergraduate degree, we have some national statistics, which are actually very similar to our statistics here at Clemson as well. We have about a third of our students who go on to get their graduate degree. So this could be a master's degree, a PhD, or going to law school or business school. We have about a third or a little bit more that like to go straight to industry. And then lastly, we'll have about a third, maybe less, that go to medical school. So this could be taking a gap year or going to straight into medical school after your senior year. So for those of you who are looking to go get your master's, or even looking to get your master's and then get another degree after that, we have two options for this. We have a master's of science and a master's of engineering. So our master's of science is research driven with an advisor, is focused on preparing you for research, maybe in industry in the future or academia and medical school. Next, we have a master's of engineering, which is more design driven, focused on preparing students for the biomedical industry. Both of them are 30 credits, and to be eligible, you must maintain an undergraduate GPA of 3.4, but if you have this 3.4 GPA, you will not have to take the GRE, which is kind of the SAT or ACT of graduate school. Another thing to point out here is that you can actually kind of double dip with some of your undergraduate courses. So as long as you talk with your advisor, as soon as you know you want to complete maybe master's of science or master's of engineering, you should say, hey, I kind of want to do one of these, and we'll set up some of your undergrad courses so that accounts for both your undergraduate degree and your master's degree at the same time. So going a little bit more about bioengineering at Clemson, our main building is Rhodes Annex. It's right next to the library, right in the center of campus, and it's where pretty much all of your classes and your teaching laboratories will be, and most of the research labs and professors' offices if you need to go to office hours. And speaking of professors, we have 30 full-time faculty. We have 2 professional undergraduate advisors who will help you select your classes, 1 professional development coordinator who will help you, look at companies to go get internships or get jobs, work on your resume, work on cover letter. And then we have about 375 undergraduate students. So that's about a little bit more than 100 per class, because remember, your first year will be in that general engineering curriculum. And then we have 138 graduate students, most of which graduated from Clemson themselves. So they're really good mentors to go ask, why did you decide to go to graduate school? What are your career aspirations after Clemson? They can be really good mentors and give really good advice to you. And they'll be your TAs and your labs and your different BioE classes. So going a little bit more of our history, we started awarding bioengineering PhDs back in the 1960s. We started giving out our MS in 1968, started partnering with NUSC, and we actually started our BS program in 2006. And we added our MEng back in 2014, actually added a new Master's of Science in Medical Device Reprocessing, which I'll touch on a little bit later in 2021, this year. So here's our picture of Rhodes. Again, this is where pretty much most of your bioengineering courses will be, as well as your teaching labs, most research labs, if you decide to do research, and professors' offices. All of our advisors are also housed in Rhodes as well, which is very helpful. And you're able to go in, ask questions, all in the same place. We have few other facilities as well, one of which is the Biosystems Research Complex, or BRC. If you've been on campus before, this is right across from Hendrix. The BRC, there's a few research labs here and some professors' offices, but Rhodes is our main building on campus. We also have the MUSC Clinical Research Facility in Charleston, South Carolina, and QBINC, which is the Clemson University Biomedical Engineering Innovation Campus, and that's in Greenville. So we have facilities in Charleston and Greenville, but I want to emphasize that all of your classes and all your labs will be in Clemson. You don't need to go get a car and go to Greenville for class or anything. Sometimes that's a misconception. All of your classes will be on campus at Clemson. Sometimes we'll video in students from Charleston for some of our classes, but all of your classes will be on campus at Clemson. So getting kind of more into the major and the classes you'll take, you'll select one or two bioengineering concentrations when you decide to be a bioengineering major. So you'll be either a biomaterials major or bioelectrical concentration. So I'm a biomaterials concentration, so it's about 80% of our student body. So biomaterials concentrations will say the body and material interactions. So if we decide to put a hip implant in someone, how is that material, how is the geometry, how are the shapes going to interact with the body, and is it going to be biocompatible? Is it going to be hemocompatible? How's it going to work inside the body? We'll also look a lot deep into tissue engineering and living materials as well. And bioelectrical, similar into healthcare, but a little bit different. They're going to study further into biomedical imaging and instrumentation. So anything with electrical current going through it, think bioelectrical, such as a pacemaker or implantable electrode, or even imaging devices such as CTs or MRIs or X-rays. And while there are two different concentrations, like we'll see in a minute, most of the classes are the same. So don't get too hooked up if you don't know which one to decide, because you'll take a lot of the same classes. So here we are. Here's our Biomaterials Curriculum. These are the classes that you'll take that are for your bioengineering degree. I excluded the different gen eds you'll have to take as well. So like we talked about earlier, we apply our physics, we apply our chemistry, we apply our calculus to healthcare. And so we got to start out freshman year with our general chemistry classes, calculus classes, physics, on and on. Sophomore year, you start to get a little bit more into the application with your intro to biomedical engineering class, learning more about material science, and then even your first biomaterials class. Junior, you'll start to apply those even more. And then senior year, you will actually take your senior design courses where you're able to apply everything that you've learned into creating a medical device yourself. A couple of things to note is that those with the orange are the classes that are going to differ between the biomaterials and the bioelectrical. Also, most of these classes are offered every semester. One exception is NOC 3190, but if you want to go study abroad or you want to go co-op for a semester, it's very doable to move your schedule around. You don't necessarily have to take this in this one semester and this in this other semester. If you just talk with your advisor as soon as you know your plans, it's easy to work around. We also have 2 seminars, BioE 2000 and BioE 4000. These are professional development seminars. You'll learn more about the industry, the 4 different types of careers, how to create a LinkedIn profile, and really set you up for success after graduation. The last thing I want to point out is the technical electives. So these technical electives are things that you're going to have to take to graduate your BioE degree, but you get to choose what you do. So some things that I've taken for my technical electives are I've taken some of my research credits. I've also taken a cardiovascular class, and I've currently taken orthopedics class. So like I said, here is the bioelectrical curriculum. So a lot of the things are the same, especially freshman year. When you get into your sophomore year, you'll take more of circuits, logic, electronics, signals and systems. So those are kind of different classes instead of like materials processing and biofluid mechanics. Those are kind of the differences between biomaterials and bioelectrical. You'll still have your technical electives in your seminar, and you'll still be able to take senior design with your biomaterials friends. So talking about senior design is a year-long real-world application of the engineering skills accumulated during your undergraduate career. So it's 2 semesters. Most people take it in the fall and finish in the spring, or you can take it in the spring and finish it up in the fall. But it is 2 semesters long. You'll work in a team, 4 to 5, and you'll be able to go onto the field and observe clinical needs and solve real problems. And you'll complete the entire design process from finding an idea and creating a need statement all the way to market. So for example, I'm currently a senior design right now. We're actually able to work with one of the physicians for the Clemson football team, which is really awesome. And you're able to see all the different things that medical device companies would create in a DHF, and which for us, it's a big binder of all the documentation that you have in creating your medical device, which you would submit to the FDA if you wanted to approve it to go onto market. And something that's really special about our senior design is that companies really do look for this in job applications or resumes, just because they know that we really go through all the documentation that you would need to know how to do. And we really understand how they do it, just like an industry, except that we kind of compress it all into 1 semester. 2 semesters, apologies, 1 year. So aside from our classes, I definitely suggest going and doing some experiential learning opportunities. So the first thing is internships or co-ops in hospitals or industry. So I was actually able to do 2 internships during my entire undergraduate career, one of which was my internship at Arthrex, but I also was able to intern at a different university. The summer after my freshman year, I researched on stem cells and gene delivery in order to treat Alzheimer's disease. And I did this as part of our research experiences for undergraduates or REU. I would also highly consider doing a co-op if you're considering it. So co-ops are less popular in BioE than I would say in other bioengineering majors, but I definitely think it's worth the industry experience. You'll be able to be at a company for a year total, but in 3 different rotations. So a fall rotation, a spring rotation, and a summer rotation. So you'll do a rotation at a company, come back, take some school, go into another rotation. I would highly suggest this. Speaking from my internship experience, I've been able to take a lot of the things that I've learned and apply it, especially to my senior design courses. And I think it really enriches your learning a lot. If you're interested in doing research, there's a lot of different ways that you can do this as well. One beginner way to do this is through the creative inquiry classes. So for creative inquiry, you'll take a class for credit, and you'll be able to work with a team and a professor working on a project. And if you visit our creative inquiry website, there are a lot of different projects that you can choose from in BioE or other majors. Really anything that you can think of is on there. If you're really more serious about research, you can then do mentor research, which is you and a professor, and even do departmental honors in bioengineering through your research. We also have a summer program with MUFC in Charleston called the Beach Summer Program. So with the Beach Summer Program, you will do some research, but you'll also do some shadowing over the summer in Charleston. And one simple thing that I really like that we do is we do a lot of lunch and learns. So our professional development coordinator, she'll set up different lunch and learns or recruiting sessions throughout the semester for us to be able to meet with industry professionals and hopefully network some, get internships and jobs after we graduate if you're looking to go into industry. And I'll quickly highlight some of the different certificates that we have. So one of which is pretty new is our Orthopedic Medical Device Product Specialist certificate. I'm also working on completing this certificate. It's within the Sales Innovation Program, which is within the College of Business. But we do have BioEs that are in this program because one of the classes that we'll take is a bioengineering orthopedics class. You'll take classes in orthopedics, but also in applied selling and selling medical devices. This is in partnership with Arthrex. And you're able to just learn more, about selling, but also about orthopedics and orthopedic devices as well. Next is the Medical Device Recycling and Reprocessing Certificate. And in this certificate, you'll be able to learn to optimize medical device designs for sustainability in healthcare. So it's 5-course sequence with different faculty and industry professionals. And this one will be available for bachelor's to graduate or graduate students. I hope that you have the chance to go international and go study abroad if you wish. And we have a lot of different programs that you can do for that. So some of our bioengineering study abroad programs include ones in Pamplona, such as in the bottom left corner there. That's where they do the running of the bulls, if you're curious, in Tokyo and other places. We also have some that are in fall or spring semesters. And you could even go as part of the creative inquiry class. We also have a pre-med program in France and Germany with Dr. Heather Dunn. So if you're interested in going on study abroad during the summer or during the semester, you'll still be able to take classes that will count towards either your bioengineering major or just your maybe different minors, whatever your degree is in general, but you will have to kind of adjust your schedule a little bit. And it's obviously, if that's just something you let your advisor know, you can work that out pretty easily. I also highly suggest getting involved beyond your coursework. So first is the Clemson Bioengineering Organization, or CBO. CBO is a great way to meet graduate students or different undergraduate students in different years, just to learn a little bit more about what that other bioengineers are doing on campus. Next is the Bioengineering Student Advisory Council, or SAC. If you were in student government high school, I would highly suggest doing the Student Advisory Council. We are able to work with different professors, different staff, and take input from our students and figure out how to create the bioengineering experience and how to make it better. We also have student chapters of professional societies. We have an honor society, Alpha, Eta, Mu, Beta, but there's also different societies at the engineering college level as well. We have a lot of students involved in Greek life, different clubs, intramural sports, social events, and different professional development clubs or events, lots of involvement on campus. And lastly, I just kind of want to close out with more of a recent example of BioE on campus and the impact that we can have as bioengineers. With the COVID pandemic, we did have our classes go online, but we were thankful to have our classes come back in person starting last year a little bit, and then mostly this year as well. So this is kind of a combination of efforts through some of our students, but also a lot of our faculty as well, creating the test for our weekly testing. So the REDDI lab, or the Research and Education in Disease Diagnosis and Intervention, was founded by Dr. Dean, who's the bioengineering professor, in fall 2020. So this lab provides weekly COVID-19 testing at Clemson University, and they can run about 9,000 tests per day. So on my side, when I go to take my COVID test every week, I just get my tube and I spit my tube and then I put it in one of those green racks and I never see the tube again. But they've been able to develop this whole process where they're able to get that and figure out whether or not I have COVID and send that back to me within the same day. And it's really helped our campus become healthier and be able to come back in person and enjoy our in-person classes again. We've also had a large grant from the state of South Carolina, around $7 million, to expand to research a little bit more beyond COVID and learn about different diseases as well. So finishing up our tour, we have some of our departmental contact information here. Tini Putman is one of our advisors. Dr. Webb is our Associate Chair of Undergraduate Affairs, and Tammy is our Undergraduate Student Services Coordinator. And lastly, here are all of our ambassadors. Like I said, my name is Ashley Babinchak. I am the lead student ambassador for this year. We also have 5 other lovely ambassadors. Their bios and information is also on the website. So if you are wanting to ask more questions, or if you're coming in person, we can definitely meet with you, but we will meet with you outside and masked. So feel free to read over our bios, reach out to someone who does things that really interest you, and we'll be more than happy to talk anything Clemson, anything bioengineering with you. So hope you have a good one, and go Tigers.